In this video, we're going to take a look at thin layer chromatography, and in fact our experiment. We've got a stationary phase, a mobile phase, and then our solutes are going to partition between those two, changing the speeds at which they move through it. We can use this to either identify compounds or sometimes, in very rare cases, purify. We're looking at a TLC plate here, a rather cheap one because it's got plastic backing. We know that the backing is plastic because it was shiny. The silica is on the matte side. Note what we're doing here is marking with a pencil lightly well above the solvent. If the solvent touches our line, it could potentially dissolve our compounds and ruin our testing. We're using pencil here because pen is made of organic materials and can potentially bleed. We would then mark roughly where we're going to put our spots, and then we would try and put our compounds onto this. Remember, our compounds have to go in solution, so dissolved in some kind of solvent. This is a pretty large empty space that we can now fill with putting our compound on. Note, we could use a pasture pipette, but the tip of this is fairly large so that when we touch it to the silica surface, it will wick out and it leaves a rather dark, large spot, meaning a lot of compound is on the plate. This can overwhelm the plate. So what we can do instead is use a special tube, a capillary tube, which is a little bit smaller and adds a significantly less amount of compound to the plate. We can then spot that multiple times, and we now have our TLC plate effectively ready to run. See that little ringlet, droplet going outwards is a little bit smaller this time around. We should verify that our sample is indeed on the plate, and we can do that by exposing it to UV light. Note again, the one that we did super concentrated is nice and tight. For our actual experiment, we've got 4 known compounds, 3 solvent systems, and we then need to identify some unknowns. These are the solvents set up in the jars, and that order will be maintained throughout the experiment. Now what we want to do is take our TLC plate and we want to verify that our compounds have indeed been placed according to the method we saw earlier. And we can put the UV light lamp up to it and you can see those spots. So we've got our 4 known compounds placed on there, and it's now just a question of running the TLC plate. So we put them into our jars, we cap them down, and then we repeat for a different TLC plate for each of these individual jars. And then we get to wait. If you look really carefully, you can see the solvent slowly rise up the TLC plates. This takes a bit of time, so with the advantage of speed, you can now see it rise a little bit better, and we can get through this kind of tedious process a little bit faster. We're waiting for our solvent to get close to the top of the plate. We don't want it to run off the top of the plate because then we'll get diffusion that will potentially disperse our spot across the plate and thereby making it difficult to see. So really we just have to wait and wait and wait. When we decided it's run for long enough, we can go ahead and take it out and immediately mark the solvent front. Okay, the solvent front is relevant because we need to use that to identify our RF values. In this case, you'll note the ethylacetate we stopped first, followed by a 90% ethylacetate in acetic acid. And again, marking that one as well. And here we're going to take it out and mark it. Note again, this time the solvent didn't go as high. You might want to think about why that might be the case for this particular solvent. Now what we've got is all of our results. So the UV lamps, you can see the now dark spot where the compound is preventing fluorescent or UV light from causing our TLC plate to fluoresce. You should be going through and pausing as necessary to go ahead and mark out the distance to each of those spots, and note that as your in-lab observation because it is important to be able to calculate your RF values. So we're going to oscillate back and forth a couple times across a couple different plates just to make sure that you can get those measurements. And we've got the acetic acid result now visually here. Part of this was to figure out what solvent we should use to test our unknowns on. Right? The solvent choice is the one that allows us to best resolve the difference between each of those individual peaks. While I didn't actually show that part of the experiment, we ran a new plate, which we're about to see in just a second here, and that was run also in the 90% elactate and acetic acid. So we've got on the left our knowns and on the right our unknowns. You should again go through, take markings for your RFs because those are relevant observations that will help you to draw conclusions from the TLC experiment. With that, we're pretty much ready to now go through and take a look at some of the potential bloopers about the technique. Okay? So these are still important, they're just not funny, but they're there. So note here we're putting that line, our starting line, way down low. If we put our solvent or put this into the solvent jar, the solvent would touch it and that would cause bleeding of our samples into the solvent. It's kind of hard to see here, but if you look really carefully, you can see little particles flying everywhere. And that's because I'm pressing so hard, I'm cutting the silica. Okay? The silica is what allows our sample to separate. If we don't have, or we cut the silica, we prevent the passage of our sample through it, which is going to make for bad testing, okay, or bad visualization of it. And then one of the last kind of bloopers that we could look at is that when we put the TLC plate into the jar, if we put it crooked, and sometimes it's difficult, for instance, our jars are fairly narrow and prevent it going in crookedly, but what you'll see is a little bit of kind of solvent running up on an angle. This is now going to change the speed at which our spots travel, and we could get false results out of this. So make sure you're careful when you go through and doing those. Thanks for watching.